In this lesson we're going to continue to look at pressure in gases, in particular the pressure of gases inside a container. So here on the left we've got a container that you're all very familiar with, which is a balloon, and you know that when you blow air into the balloon, the pressure in the balloon increases. Well, what's actually happening to the particles inside the balloon? Well, we've got a whole load of particles in the balloon, air particles, and these particles are moving randomly, and they're moving with a whole range of different speeds and in different directions. So what's going on inside the balloon? Well, these particles are colliding with each other, and they're colliding with the walls of the container. So if we look at the wall of this balloon, for example, magnified, it may look like this. And at any one time you've got particles colliding with the walls of that container, like this. Each time the particle collides with the wall, it produces an impact. That's a small force acts on the wall. So the pressure really is the average effect of all of these impacts on the wall of the container. So what we're going to learn in the next two lessons is that this pressure depends on a number of factors. So the next thing we can say is that this pressure acting on the wall of the container depends upon, first of all, the speed of the particles as they collide with the container, and secondly on the number of collisions that are taking place per second. That's to say, it's the average effect of all of these collisions. And that in turn depends upon two important factors, which we shall look at in the next lessons. First of all, it depends upon the number of particles that are present in a given unit volume. So as you increase the number of particles inside the balloon, that's to say you're increasing the number of particles per unit volume, you know that the pressure in the balloon will increase. Now the other factor that the pressure depends upon is the temperature of the gas. The hotter the gas, the faster the particles move, and so the greater the impact or force exerted on the walls of the container, and so therefore the greater the pressure in the container. So what we're going to do is we'll look at these two cases on their own in the next two lessons.